A very good morning to Miss Christy Wong and my fellow friends. My name is Mary Beverly Roni Pidur, and today I am going to do a simulation and example for mini project Hydrology DCC 50212. Before that, I would like to introduce the software that will be used on completing this project, which is HEC-HMS. This software is widely used in hydrological studies due to its versatile applications. It plays a vital role in flood forecasting and analysis by predicting peak flows and runoff during storm events. The software is also useful for watershed and catchment modeling, helping assess how different rainfall patterns affect specific areas. In reservoir and water system operation, this software stimulates inflow to support dam management. Additionally, it aids in urban drainage design, ensuring efficient stormwater management in cities. When integrated with other tools, HEC-HMS can be used for water quality and sediment transport studies. HEC-HMS offers many benefits in the field of hydrology. It provides accurate runoff prediction, which helps engineers and hydrologists better understand how stormwater behaves during rainfall events. The software serves as a decision support tool, supplying reliable data for flood risk management and planning of water infrastructure. It is also a cost-effective stimulant, reducing the need for physical and extensive fieldwork. This software supports integrated water resources management by promoting collaboration among different agencies for basin-wide water planning. Furthermore, as an open source and globally accepted tool, it is freely accessible and widely used in both academic research and professional practice. This software also plays an important role in promoting environmental sustainability. It supports responsible water management by helping to prevent water overuse and ensuring efficient distribution of resources. The software also helps in reducing flood risk through predictive modeling, which assists in designing infrastructure that protects both communities and natural ecosystems. In urban development, HEC-HMS encourages eco-friendly planning by integrating hydrological data into sustainable stormwater systems like green roofs and permeable pavements. Additionally, it is valuable for evaluating the effects of climate change, offering insights into future water availability and extreme weather events to support proactive environmental planning.
So here is the HEC-HMS software look like. First, we need to create new project, and in this project I will name it as our catchment, which is according to the question. And for the description, I will put 25 ARI 3 hour. So we need to press 3A, click component, create component, and create a new basin, and the name is also 25 ARI. Same goes to the description. Next, we need to create the meteorologic model, and the name is also same, which is 25 ARI. Next is control specifications, and the last one is time series data. For the name, we need to put Gunung B. We need to put Gunung B following the question, and make sure the data type is the precipitation gauges. Create the sub-basin for the basin models. For the first sub-basin is C1, and the second subbasin is C2 and the last one is C3. And create one sink element and connect the subbasin to the sink element. Next, we need to fill the information for each of the subbasin. The data insert here is the database from the question given. Make sure to fill in all the data. Last one is C3. Fill in the area, the initial loss, the constant rate, impervious percentage, time of concentration, storage coefficient, and then initial discharge, recession constant, and ratio. Next, fill in the data for the meteorologic models. Click yes over here. And for the control specifications, for the start date also need to be filled based on the data given in the question. For the time series data, adjust the date, month, and year, and also the start time and end time. Ensure the time interval was 15 minutes. For the precipitation table, this table also need to be filled in based on the data given on the question. here we can see the graph of the precipitation. Next, we need to create a compute and run a simulation for this data. Press the simulation runs and run, and then click the run icon. Seems like I forgot to fill in the hydrograph data. Okay, so here we need to click the gauge 1 for each sub-basin. Then proceed to run the simulations. Close, and here we can see the results for all the sub-basin and the sinks, and also the global summary. This is the data for the global summary. And here we can see the graph for the sub-basin 1. Also see the summary table, and same goes to the sub-basin 2 and sub-basin 3. We can also see the data for the sink graph. That's all from me for this presentation. Thank you for your attention.